Object-oriented programming. In this video, we will introduce the concept of object-oriented programming. First off, what is object-oriented programming? Object-oriented programming is a programming style that focuses on objects and the data and actions associated with those objects. What is an object? Well, the textbook definition of object is a structure that has both state and behavior. Now, what do I mean by that? Well, state is just another word for data, and behavior is just another word for methods. To help us understand what is an object, let's discuss what is not an object. Primitives are not objects. Ints, doubles, chars, booleans, these are all examples of primitives. These are not objects. These types contain data, but they do not contain methods. Just think about it for a second. Have you ever called a method on an int variable, or a double variable, or a char variable, or a boolean variable? Of course not. These variables contain data, and that's it. Now, what is an example of an object? One example you're most certainly familiar with are strings. As you know, strings store data, more specifically, a sequence of characters. Strings also contain methods that we use to operate on that data. Methods such as the length method, the char_at method, the substring method, the index_of method, contains, so on and so forth. Another key difference between primitives and objects is that when we create objects, we use the new operator to create them, whereas with primitives, we do not. For example, when creating an int variable, we don't say new int, we just put the value. Likewise, we don't say new double when creating a double, or a new char when creating a char, or a new boolean when creating a boolean. For string, however, we do use the new operator when we're creating a string. We say string str equals new string, then with the value that we want inside parentheses. Now, Java does provide an alternative way to create string objects, but as you move further along in your computer science journey, you will see that this is the exception, not the rule. The vast majority of objects provided by the Java library do not allow an alternative form of creating it. The new operator is required for the vast majority of Java objects. That being said, strings are one of many types of objects the Java library provides for us. Java also provides us the ability to invent our own objects. We do this by creating a class. A class is a template for a new object. For example, rectangle. Suppose I want to give myself the ability to create rectangle objects in a program. Well, the first thing I need to decide is what data do I want this rectangle to store? For this example, we'll just say our rectangle will just store the length and the width. Next, I need to decide what actions do I want my rectangle to be able to perform on this data. For this example, we'll simply say compute the perimeter and the area of the rectangle. So let's write the code for it. The first line, we put public class, then rectangle. Anytime you're creating a new class, you're always going to begin with the keywords public class. That's not going to change. What changes is what follows. For this example, we're creating a rectangle class, so rectangle is what we're going to type. After that, on the next line, we need to type the data. Okay? In this case, length and width. Now notice I chose to declare length and width as int variables. That's because that's the data type that makes the most sense for how I intend to use length and width. I could have also declared them as doubles, and that would have been fine. Obviously, we can do addition, multiplication, and other math operations with doubles. Either one would be fine. Once again, it just depends on how you intend to use the class. For this example, we'll just stick with ints, since ints are generally simpler to use. Next, after declaring your instance variables, the next step would be to write code for your actions, the methods. But we're going to save that for another video. For this video, we're just going to focus on the data. So now that we got our data declared, let's open up our main method and demonstrate how to create a rectangle object. This line of code demonstrates how to create a rectangle object. Now let's break it down piece by piece. What did I just do here? The first part is the data type that we're making, in this case, rectangle. The second part is the name of this rectangle object that we just created. In this example, we simply called it rec. On the other side of the equal sign operator is the new operator, the new keyword. Once again, we use the new keyword whenever we're creating a new object. That's then followed by the data type, which is rectangle, and a pair of parentheses. This creates the rectangle object. So now that the object is created, this begs the question, what is the length and width of this rectangle? Well, the length and width is currently 0, since 0 is the default value for an integer. This then begs another question. How do I change the length and width of my rectangle? For example, suppose I want my length to be 10 and the width to be 5. Well, here's how I'll do that. I would say rec.length equals 10 and rec.width equals 5. In general, to access data within an object, I have to type the following in this order. The name of the object, which in this example was rec, followed by the dot operator, then followed by the name of the data that I want to access, which in this example was the length and the width. I'll also take this opportunity to introduce a couple important vocabulary words. First of all, rec is an instance of the rectangle class. Every time I create a new rectangle object, I'm creating a new instance of the rectangle class. Length and width are instance variables of the rectangle class. Each instance of the rectangle class will have its own length and width. For example, if I were to continue writing code and create a new rectangle object called rec2, rec2 would be a new instance of the rectangle class, and it would have its own instance variables. It would have its own length and its own width. If I wanted the length to be 8 and the width to be 4, I would say rec2.length equals 8 and rec2.width equals 4. In writing this, I only changed the width and length of rec2. I did not change anything inside rec. Now let's say I want to compute the area of rec2. I could declare an integer named area and set it equal to rec2.length times rec2.width. Since rec2's length is 8 and the width is 4, when I print out the area, I get 32 as my output. Let's look at another example of creating a class. Suppose I want to design a class that represents a student. First, I need to decide what data do I want this class to store. We'll say name, grade, and GPA. Next, I need to decide what actions do I want this object to be able to perform on its data. We'll say I want this object to be able to determine its classification and its academic distinction. All right, so let's write our code. First line, public class, student. Once again, public class will always be how we start things off. Student, in this example, will be the name of our class. Next, I need to write out the data. I need to declare the data. I'm going to use a string for the name instance variable, an int for the grade instance variable, and double for the GPA instance variable. Once again, I chose these types because these are the types I felt makes the most sense for how I intend to use the data. Now, once again, we're not going to write code for the actions yet. We're going to save that for another video. For this video, let's focus just on the data and how to create a student object. So let's open up our main method. Then in the next line, we're going to create a student object named st1. Once again, I did that by first writing out the data type, which is student, then the name of that object, st1, followed by the new operator, and then once again, the name of the data type, student, and a pair of parentheses. Now I'm going to change the name. I'm going to say st1.name equals Alex Rodriguez. I'm going to say st1.grade equals 11. And st1.gpa equals 6.51. Now that my student object is now storing the data that I wanted to store, I can now, if I so choose, print it all out in one line, separated by a comma and a space. If I do that, it would look something like this. Okay, system.out.print st1.name, followed by a comma and a space, followed by st1.grade, followed by a comma and a space, followed by st1.gpa. When I execute this program, this would be my output.